So in this video, we're going to go over the squeeze theorem. And then in the next video, we'll use the squeeze theorem to find a limit. So here's the idea. The idea is that you want to find the limit as x goes to a for some function g of x. And maybe that limit is difficult to find. So here's g of x. But the squeeze theorem says that if you can find two functions f and h so that g is always between the functions f and h. So here we have h is above g of x always, f of x is always below g of x over some open interval. So in other words, if we find that f is less than or equal to g is less than or equal to h, if f and h both have the same limit as x goes to a, then g has to have the same limit. And the idea is we have a three-part inequality here. We take the limit to each of the three parts. So we take the limit as x goes to a of f, which has to be less than or equal to the limit as x goes to a of g, which has to be less than or equal to the limit as x goes to a of the function h. But if the limit as x goes to a of f is L, this is going to be less than or equal to the limit as x goes to a of the function g is less than or equal to, and if this limit is also L, that tells us that the limit as x goes to a of g is between L and L, but L is just a single real number. So that tells us that all three functions are going to have the same limit at a. So that's the squeeze theorem. The idea is for the squeeze theorem, I want to find the limit for a function. I find two functions that for which the function I want is squeezed between them, and then if I can show that the two functions I've squeezed g between have the same limit, then I know that g has the same limit as those functions do.